Okay, well, now we'll go on to move on to our final guest, and we have waiting for us, hopefully, our good friend and the most knowledgeable person we know on all things US spaceflight, Gavin Price. Gav, are you there?
Looks like.
Hey! Glasses charged. How's lockdown treating you, Gav?
It's going well. I'm using the time to utilize and try and research and possibly put together a book on Apollo.
Oh, wonderful.
Oh, at last.
Possibly.
No.
There is no try, only do.
Cross that word off. It's going to happen. Yeah, look, people on the chat
are going, yes. Destin has said, woohoo, the Apollo savant.
Yeah, it's something I've considered for a while, and I've been encouraged by a lot of my friends online. But if you're trying to write a book about Apollo, what angle do you write about which hasn't been covered before?
Yeah.
Mm-hmm. You can talk the astronauts, they've had their biographies written. I think Neil Armstrong's had 5 or 6 books written about him. You can't really talk about the politics because that's been covered extensively. Then you talk about the hardware, Kennedy Space Center, the Saturn V, the Apollo Command. It's all been done. So trying to find an angle which is new and fresh and will bring some new information out is quite difficult. But I think I found an angle which.
I'll hold it here. Don't tell us. Leave it as a surprise when you write the book and you send us a copy to review on the podcast.
Will do.
Well, as we're 50 years and a day from Apollo 13 limping its way back to a safe return, can you give us a brief overview, Gav, of the Apollo 13 mission and what happened on the way to the moon? So kind of the mission as it's occurring now 50 years ago.
Yeah, so I think a lot of people watching this this broadcast will be aware that it's 50 years since Apollo took off from the moon, and they launched 50 years ago last Saturday. One Saturday evening, myself and my partner, we sat down to watch the movie Apollo 13. Great movie. It's very well done, very well thought out with input from the astronauts and the flight controllers who worked at Johnson Space Center. But after I finished the movie, I thought, I don't actually know a lot about the mission and what went on. So what I decided to do was go through the air-to-ground transcripts, the communications between the crew and the spacecraft, and the mission controllers on the ground, or the Capcom, the only person who would talk to the crew. And there's this website called the Apollo Lunar Surface Journals.
Have you seen Apollo in real time too?
Yes, I've watched a bit of that. But I've purposely shied away from looking at that this time, as opposed to Apollo 11. Because on this Surface Journal, it's written by NASA historians and people who've put together so many books on Apollo. And what they do, while the crew are talking to the Capcom on the ground, the people who put together this website will actually break down what they're talking about. So if they're talking about a certain system which is broken and how the astronauts are going to fix that system, it'll give a graphic and a brief description of what the astronauts are talking about, so you can really get down in the mud and try and understand what's actually going on, rather than the astronauts reading down a whole bunch of numbers and things that the general public, like myself, are not really keyed up on. So I spent the last 6 or 7 days just diving into that really and trying to understand what actually went on with Apollo 13. One of the things I found out was the oxygen tank in the service module, just behind the command module where the Apollo astronauts sort of lived on their way to the moon. It exploded, and that explosion can be traced back to 1962, in fact. So this wasn't something that happened over a couple of days or a couple of months. This explosion had been in the making for the best part of a decade.
Why is that?
So, as you're probably aware, there were over 20,000 contractors involved in building the software and hardware for Apollo. And the specifications were given to North American Aviation to build the command and service module, the cylindrical service module which held the consumables and which would provide electrical power to the command module, the sort of conical shaped structure where the astronauts lived. And the specifications given to North American Aviation, the systems were supposed to run on 28 volts. So they built the spacecraft and the oxygen tanks to 28 volts. Unfortunately, the ground support equipment at Kennedy Space Center, where they tested all these systems individually and in an entire stack before flight, they were rated to 65 volts. So when they came to do tests, the electricity that was running through these systems was more powerful than what they were designed for.
Yeah.
And the tank that actually blew up on Apollo 13, it was due to fly on Apollo 10 in May last year, or May 1969. And they removed the tank to do some maintenance on Apollo 10. And rumor has it was dropped 2 inches. And that affected a drain line at the top of the tank. And one of the things they do before a Saturn V launch is something called a countdown demonstration test. And one of these tests would be wet. And what that means was they'd fuel up the Saturn V, they'd fuel up the hydrogen and oxygen tanks, which would power the fuel cells. Test that everything's okay, then drain all the fuel out. But because one of the feed lines on the oxygen tank was knocked ajar, they couldn't actually drain this oxygen tank in the normal way. So they decided just to heat the tank up with a couple of fans and heaters. And they ran those fans and heaters, I think it was for about 8 hours. And of course, it was running at 65 volts rather than 28. And the temperature inside the tank, I think it went up to 1,000 degrees Fahrenheit. And no one knew at Kennedy Space Center it had burned off all the Teflon insulation within the tank. Of course, they sent it on its way to the moon then on Apollo 13.
Wow.
So it was a whole chain of events.
It's a whole series, isn't it?
Yeah, and ultimately it was a breakdown in communication. You have something within the Apollo program called prime contractors and subcontractors. So a prime contractor would build things like stages of the Saturn V, the command and service module, and the lunar module. Or even for the prime contractors, they didn't have enough labor, enough manpower to build these systems. So then they'd subcontract out certain subsystems within our overall structure. So a subsystem would be the oxygen tanks for the service module. And the specifications, when they changed, they weren't communicated to the subcontractor.
It's so frustrating to think that that was just sat there all that time, just waiting to blow when it came into use, and people were launched with that in the spacecraft. But then also so incredible to think that you could have an explosion like that in a spacecraft that ultimately didn't blow up the spacecraft or rupture the skin of the spacecraft. The astronauts were able to survive. So given that as we look at the calendar now, 50 years from their return to Earth, what were the kind of decisions that were going on in the spacecraft and at mission control now, and the kind of threats that were ahead?
So I think it's interesting, when I've been diving into the air-to-ground transcripts, is the flight director, Gene Krantz, quite rightly, he got a lot of praise in the movie and the subsequent press releases for the role he played in leading the teams in mission control to get the crew safely back to Earth. Gene Krantz was only on shift for, I think it was about 2 hours just after the explosion. And he was sort of fire shooting immediately. What are we going to do? What systems are we going to shut down? He then swapped his shift out with another flight director. And that's when Gene Krantz led a Tiger team to actually look at some of the long-term problems that were going to occur, 3, 4, 5 days down the line. The next person on shift was a flight director called Glyn Lanny. And that's when his shift really started to bottom out the procedures and stabilize the situation. And I've spoken to a couple of flight controllers within the last few years, actually, and a lot of them have told me within 2 hours of the accident, they were confident they'd get the crew back home. But then they went on to say, we'd get them back home. We didn't know if we'd open up the hatch, they'd be dead or alive. They were confident of getting that spacecraft back to Earth.
Yeah. And of course, wasn't there, and I'm aware that a lot of my knowledge of Apollo kind of blends in from the book to the film, particularly Apollo 13, and it's difficult to separate the two when it's been a while since you've read the actual books and Jim Lovell's book. But wasn't there also an issue that they weren't sure whether the parachutes were going to open and that there was bad weather, or was that from the film?
So I can't really comment on the parachutes and the bad weather because I haven't got that far in the air-to-ground transcript yet. So I know there was a typhoon within the vicinity of the Pacific where they were looking to bring them down. I don't think that was an overriding concern. One of the big differences I've picked up on between the film and the actual timeline for Apollo 13 was that I couldn't see many decisions being made on the hoop, sort of knee-jerk reactions. A lot of the decisions that were made as the crew was sort of stranded in space, they were thought through, then they were simmed on Earth in the simulators, read up to the crew, and the crew repeated them. And actually, a lot of the procedures, I don't know if you can remember in the film, one of the burns of the lunar module engine to push the spacecraft stack back to Earth, Jim Lovell is sort of controlling the lunar module manually. Yeah. And he's got the Earth bouncing around in his window. He's trying to keep it centered in the window. And diving through the documents, they'd actually simmed manual navigation on Apollo 8 the first time they went to the moon in the Apollo program. And in the lunar module, they had procedures for that burn, that manual burn as well. So these things had really been thought about. There was very little that NASA didn't think about in terms of what could go wrong, what procedures do we need to have in place to mitigate such disasters.
Yeah. And one of the questions that's come in for us as we're going through this is, was there such a thing as software on Apollo? Wasn't all the computer processing a physical process?
So I've been reading a few books about the Apollo guidance computer. This sort of briefcase-like structure, which was fitted into, there was one in the command module and one in the lunar module for the lunar landing. And the way the astronauts interacted with the Apollo guidance computer was something called a disk key. A couple of numbers, a 5-level display. And the Apollo guidance computer is a bit of a misnomer in that after the Apollo program started, MIT were going to design the computer to guide the spacecraft. That was going to be its primary function. But NASA since realized, after they gave the contract to MIT, that they would be more accurate guiding the spacecraft from the ground. So you know the deep space sky network today that we track spacecraft around Mars, Juno around Jupiter. They've got dishes in California, Madrid, and I think it's Canberra in Australia, equally spaced 120 degrees apart around the globe. So you have global coverage. They could actually track the spacecraft more accurately from the ground than what the computer would. So the computer was actually a sort of redundancy system for navigation. And I know at the time the engineers in MIT were quite pissed because their primary function for the computer was taken away. Well, what they got was something bigger entirely. The Apollo guidance computer actually became the digital autopilot. That was the thing that would fly the Apollo spacecraft in terms of deep space maneuvers, working out the velocity changes, how long it needed to burn for, setting the right attitude of the spacecraft before it needed to burn as well.
Yeah.
In terms of the software, I'm not a software engineer. There were software programs written for the Apollo guidance computer. and these software programs were very limited because the memory in the computer was limited as well. So the astronauts could actually key in a program, return to Earth. And if they were around the moon, the program would actually fire that spacecraft to get them back to Earth, as long as the astronauts uploaded certain parameters that were given to them from the ground, whether that be attitude sightings from star sightings, how much velocity they needed to gain in feet per second, things like that. So it was a very capable system in the end, it was fundamental in actually landing Armstrong and Aldrin on the moon. They couldn't have done it without digital autopilot.
Yeah, it's incredibly capable when you think how primitive it was and just how much computers came on because of what was done through the Apollo program. But finally, we've got an email from Peter Ellinger in Sheffield, England, who asks if we were aware of the BBC World Service podcast 13 Minutes to the Moon, which I'm not familiar with, but Peter says that season 1's on Apollo 11 and the current season 2 is on Apollo 13. Not a minute-by-minute playback, says Peter, but plenty of stuff from the astronauts, their families, mission control, and the backroom boys and girls. Great soundtrack too. All in all, something the BBC has done right for a change. Is that something that you've heard, that you've listened to, Gav, that you'd recommend?
Yeah, certainly. I believe it's from primarily produced by a chap called Kevin Fong, who used to work for NASA on the space shuttle program. And I believe he's actually stopped the podcast at the moment because he is a doctor, and he's gone back to work for the NHS in the middle of the coronavirus, which is, is very admirable. I did listen to the 13 Minutes to the Moon podcast for the Apollo 11, but I've been so absorbed in Apollo 13, just reading about it, I haven't actually managed to get a chance. But I know Kevin does really get down into the dirt with these people who were instrumental in bringing that crew back home.
We've got a few people actually making comments about the 13 Minutes to the Moon podcast. Tony Horton has said that they're brilliant. Averted Vision has popped back up saying that the soundtrack is absolutely stunning. It's a great watch. I guess that's to do with the podcast. Maybe not. I don't know. But yeah.
13, the film.
Or is that Apollo 13, the film?
The film?
Do you reckon? Because I mean, if it's a podcast, it's not going to have...
It's not going to have visuals.
Visuals. Well, I don't know. We've got visuals.
Here we are.
With visuals.
Can I just make another point on Apollo 13?
Yes. Averted Vision has said, yes, the film. So thank you for that.
Carry on, Gav.
Yeah, I think it's interesting to compare the architecture that NASA went to the moon with Apollo back in the 60s and 70s. And for those who are familiar with the Apollo architecture and actually how NASA got to the moon, they were sending two spacecrafts, the command and service module, which the astronauts would launch in, and ultimately which they would come back through the Earth's atmosphere, and the lunar module, which would take two astronauts down to the lunar surface. They could do an EVA, pick up some rocks, come back up and rendezvous with the command module around the moon. Now, if we look today and some of the architectures that are being put forward for going back to the moon, we don't have similar architectures in terms of that level of redundancy. So if you take Orion, I think on Artemis 3, they're planning to send a crew around the moon in this new Orion space capsule. If something like Apollo 13 happened on Orion, the astronauts are dead. There is no lifeboat scenario there. They're going to be stuck in orbit in the solar system for forever. And even with something like revolutionary as Starship, it's one system. And if that system goes wrong, there isn't a lifeboat scenario. There's nowhere else that astronauts can sort of transfer to, like the lunar module. So I think it's very interesting to compare, even though it was 50 years ago and what we would view as primitive technology today, the systems we can go back to the moon with, if something untoward was to happen, it's very unlikely those astronauts would get back safely.
That is a terrifying thought as well. I mean, it shows what confidence they must have in the architecture that they're building for Artemis, the next moon missions. But also, it's quite frightening that they're not building that redundancy into it.
Yeah, and one thing I've learned about Apollo, certainly the transition from the Apollo program into the shuttle program, is that one of the main reasons Apollo succeeded was the level of testing they did within the program. They were flush with cash during the Apollo program, and they can do a really extensive testing program, and not just testing the entire spacecraft or subsystems, but even individual components. Things like microchips were tested in their thousands before they ever flew. And you can sort of see that the testing program gradually fell away as they transitioned to the space shuttle. And ultimately, it was testing failures and management failures which killed 14 astronauts on the space shuttle. And I don't really see that level of testing. I haven't seen that level of testing since Apollo.
Yeah. Well, thanks very much, Gavin. It's been an absolute pleasure speaking with you. Just as a final thought, is it too early to say when you're expecting your book to be completed, or is
I'm in the very, very early stages, so you're probably looking at a couple of years.
I can't believe you've not got the project plan.
Oh.
Thanks very much, Gavin. Take care.
Thank you. Bye.
Bye.
If anybody does want to follow the remainder of the mission with the capsule and mission control audio, the spacecraft details and mission photography, just go to apolloinrealtime.com. And as Gavin was saying there, I've made a note here, Google Apollo Lunar Surface Journal if you want some of the more of the jargon explained as well.